79% of GRE students are getting this wrong. It's genuinely shocking. I'm Erika here with Target Test Prep, and today I want to share some pretty surprising information about what might be the hardest GRE math questions. And I'm going to do it with some example questions that stump the vast majority of Target Test Prep students. So I was doing some video research the other day trying to find the hardest GRE math questions in the Target Test Prep program, and I ended up pulling a list of the most missed Target Test Prep questions, or the questions that the fewest Target Test Prep students get right. And what I found was really interesting. Now, there were some things that weren't a huge shock. There were a lot of combinations and permutations questions. Not super surprising, most people don't have a lot of experience with these before studying for their test. There were also a lot of roots and exponents. Okay, maybe not as esoteric as combinatorics, but still a lot of rules to memorize and apply, so fair enough. But these weren't the things that came up the most. No, the thing that came up the most was number properties. I'm talking evens versus odds. I'm talking positive versus negative versus zero. I'm talking integer versus non-integer, multiples, factors, divisibility, prime numbers. The stuff that's tripping graduate school candidates up the most is stuff that you learn before you turn 10. So why are test takers getting questions based on these extremely basic concepts wrong? Well, let's take a look at two example problems that exemplify two different number properties pitfalls. We'll start with a slightly easier one. This is one of the top 25 most missed GRE quant questions gotten wrong by 71% of students. Okay, pause the video if you want to give this problem a go on your own. So this problem wants us to find this expression's greatest prime factor. So we should start by factoring. I'm going to start with the numerator, 1 because there's more going on, and 2 because there is addition. Factoring is multiplication, so ideally I want to get rid of the addition by factoring and then simplifying until the numbers are small and easy to add. All right, so I see that there is a 10 factorial in both terms in the numerator, so I'll start by pulling that out. So that's going to give me 10 factorial times 11 factorial from that first term, plus 9 factorial from that second term, all over 111. Okay, in my parentheses, I have an 11 factorial and a 9 factorial. Since 11 factorial is a bigger factorial than 9 factorial, I know that 11 factorial has a 9 factorial in it that I can factor out of both terms. So pulling that 9 factorial out, I have 10 factorial times 9 factorial. And then in my parentheses, left over from my first term, I'm going to have 11 times 10. And then left over from my second term, I'm going to have a plus 1. Don't forget about that plus 1 when factoring. That is a classic mistake. And then all of that is going to be over 111. Okay, now the math in my parentheses is simple enough. So 10 factorial times 9 factorial. 11 times 10 is going to be 110, plus 1 is going to be 111. My addition is gone. And hey, look. Now I have a 111 in my parentheses, which is the same as the 111 in my denominator. I can cancel these both out, leaving me with 10 factorial times 9 factorial. Didn't even need to factor the denominator at all. Okay, so what is the greatest prime factor of 10 factorial times 9 factorial? Well, we can create a ton of different factors by multiplying different combinations of the integers that make up 10 factorial and 9 factorial, but those will all be composite. Prime factors have to be one of the consecutive integers already in the factorials. So looking at 10 factorial, we have 10, not prime, times 9, not prime, times 8, not prime, times 7. That is prime. So 7 is going to be the greatest prime factor of 10 factorial. And then 9 factorial is a smaller factorial than 10 factorial, so we know it doesn't have any prime factors or factors in general that 10 factorial doesn't have. So the greatest prime factor for the expression is 7, or answer choice D. Let's try the slightly harder problem, and then we'll discuss them both. This is one of the top 10 most missed GRE quant questions, with 79% of Target Test Prep students getting it wrong. Okay, once again, give the video a pause if you want to try this one on your own. Now, if you started this problem by jumping straight into calculation, You are on the wrong path because something from this question stem should jump out at you immediately and shape your approach to the problem. And that's the word non-negative. And that's because non-negative doesn't just mean positive. It means positive or zero. Now, zero is a classic number properties edge case that turns problems on their heads, so we need to bear it in mind as we solve. Okay, so our expression is the product of all the non-negative one-digit numbers. So that's going to be 0 times 1 times 2 times 3 times 4, all the way up to 10, divided by the sum of all the non-negative one-digit numbers. So that's going to be 0 plus 1 plus 2 plus 3 plus 4, all the way up to 10. Now, rather than actually calculating, I'm just going to think about what the 0 does to this expression. Now, in the denominator, we're just adding it, so it literally doesn't do anything. We can get rid of it. So our denominator is going to be 1 plus 2 plus 3 plus 4, all the way up to 10. But in the numerator, we're multiplying, which is very different because we know that multiplying anything by 0 gives a product of 0. So it doesn't matter what we get when we multiply 1 times 2 times 3 times 4 all the way up to 10. Because when we multiply it by 0, the whole numerator becomes 0. Now, at this point, we also know that 0 divided by anything gives a quotient of 0. So it also doesn't matter what 1 plus 2 plus 3 plus 4 all the way up to 10 is. Because our numerator is 0, our quotient will be 0. So the quotient of our expression is 0, or answer choice A.
So why do so many students get number properties questions like these wrong? Well, 1, they discount learning the basics. A lot of people skip straight past number properties because it sounds easy and they think they've got it in the bag, but the stats don't lie. That first problem didn't have any super tricky traps or require any huge leaps in logic, just an awareness of factorial notation and a basic understanding of factoring and simplification. And yet, about 2/3 of students get it wrong. But more insidiously, too, the seemingly simple nature of these questions causes test takers to let their guard down and forget that most quant questions, especially harder quant questions, aren't really testing math. They're using math to test critical thinking. That second problem hinged on our understanding of one word, non-negative, and the edge case it introduces, 0, rather than on any complex calculations. It's actually pretty similar to the kind of logic we see in verbal questions. In the end, this question should be solvable in under 30 seconds, but still more than 3/4 of students are getting it wrong, and that's after spending way more time doing worthless calculations. Takeaway, if you want to be one of the rare test takers that do get number properties questions like these correct, 1, brush up on your fundamentals, and 2, keep the design of the test in mind. Now, like I mentioned, combinations and permutations and exponents and roots were also heavily represented in the set of most missed target test prep quant questions. So let me know if you'd like a video on either of those topics. They really don't have to be as hard as they seem. Don't forget to like and subscribe for more videos from me every Wednesday. Thanks for watching, and I'll see you in the next one.